Hello dear technology and creativity enthusiasts, welcome to this new video, which is about the ultrasonic sensor and controlling it with the Arduino board. Ultrasonic sensors are an essential component in the field of robotics. They can be used in various electronic projects due to their ability to measure distances without contact. Among the most popular ultrasonic sensors is the HC-SR04 sensor. This device provides excellent distance sensing at a very low cost and is widely available. It can measure distances from 2 cm to 400 cm with an accuracy of up to 3 mm, making it suitable for a wide range of applications. Now let's learn how an ultrasonic sensor works. It operates by sending an ultrasonic wave at a frequency higher than humans can hear to an object and then listening for the echo of that wave. By calculating the time between sending and receiving, the distance can be determined. Usually, the device consists of 2 main components, a transmitter and a receiver. This is the transmitter, then the receiver. First, the ultrasonic waves are transmitted such that the transmitting side of the device emits a sound pulse, an ultrasonic wave at a frequency generally above the human hearing range, about 40 kHz. The blue signal, and then the reflection of the sound waves. When these waves hit an obstacle or object, they bounce back towards the device, often referred to as the echo signal. Then the echo is received. The receiver part of the device detects this echo by accurately measuring the time it takes for the echo to return. Distance calculation is usually done by measuring the time period between the moment the sound wave is emitted and the moment the echo is received. Using the formula distance equals time multiplied by the speed of sound divided by 2. The division factor 1/2 is used because the sound wave travels to the object and back to the device, covering the distance twice. As you see, it travels and then returns, so we have the distance multiplied by 2, hence dividing by 2 to get the one-way distance, knowing that the speed of sound in air is 340 meters per second in standard conditions. Now we will use the Arduino board to measure the distance. We will connect the sensor to the Arduino board as shown in the picture. Now I have set up the setup. As you can see, I have the sensor here, then I have the Arduino Uno, a board matching the Arduino board. I have connected the board to the sensor as shown in the diagram. Here GND with GND and VCC with 5 volts from the board, then trig with pin 9, and echo with pin 10 on the board. I will now program the control board to measure distances using the sensor. Here, I defined pin 9 as the trig pin through which we will send the signal to emit the ultrasonic wave, then pin 10 as echo pin to receive the signal that comes through the echo. Then in the setup function, we define the trig pin to be an output, then the echo pin to be an input. Then we activated the serial communication so we can receive the information via USB port. Then in the loop function, which repeats continuously, we defined these 2 variables duration and distance as long. Then through this function, we set pin 9 to be low, meaning 0 volts, then we waited 2 microseconds, then after that, we set it to high, meaning 5 volts, and waited for 10 microseconds, then set it to low again, thus ensuring through these lines to send the signal to emit the ultrasonic wave. Then here we calculated the time duration through this pulse-in function. This function measures the length of the incoming pulse, which is then converted to distance using the speed of sound, where distance equals this time multiplied by the speed of sound divided by 2. This way, we get the distance in centimeters, then we read this distance and wait each time for 1 second. I will now upload this program to the board. After uploading the program, I will open the serial monitor, and here you can see the distance values that the sensor reads. Here is the sensor fixed here. I used this ruler to measure the distance or verify it, and I will use this board. As you can see, the board is now 4 centimeters away. I will move it, and as you will see, the measured value will change. Now, about 8 centimeters. I will now connect a display screen to the control board to measure the distance. So displaying the distance measurements from the ultrasonic sensor on an LCD will enhance usability, so we won't need the computer anymore. We can read the values directly from the screen. So, in addition to the control board and the sensor, we will need an LCD with an I2C adapter. This adapter will be added to the screen, making the connection to the control board easier. Now, I have set up this setup to measure the distance and display it on this screen. As you can see, we have the sensor, then the control board, then the screen, and this I2C serial adapter. I will now program the control board, and here is the program. We will need this liquid crystal I2C library, which will make communication via the I2C protocol with the screen easier. Then we have this NewPing library, which will make handling the ultrasonic sensor easier. Then we define this pin 9 to be the trigger_pin and pin 10 to be the echo_pin. Then we define a maximum distance. Then we set up the screen through this function. Then we set up the sensor through this. Then in the setup function, we initialize everything through these commands. Here we will write the word distance. In the loop function, which repeats continuously, we wait 50 milliseconds, then in this variable distance, we save the value that the sensor measures, then on the LCD we try to display this value, changing the position of the writing. Then we check this value. If it's greater than 0, we print it using LCD print, then we write cm as the unit of measurement. If this distance is less than 0, we print LCD print air out of range. Then the program restarts from line 19. I will now upload it to the board. As you can see, the screen now shows values. I will now change the distance between the sensor and the board. As you can see, the measurement values can be displayed on the screen. When changing the distance between the sensor and the board, the measured value changes. And this brings us to the end of today's video. I hope you enjoyed and benefited from it. Don't forget to like the video and subscribe to the channel to stay updated with all the new content. Share your ideas and inquiries in the comments. Until next time, stay creative and keep exploring.